Hello everyone, welcome to this new video where we are going to go through range sum of BST. I don't know what the BST is, but okay, so we are just going to find out the sum of element of a tree appearing in a given range. So let's say we have this tree for instance, and we have for range 7 and 15. What we are going to do is that we are going to loop through all of the elements of the tree. If the element is in this range, what we are going to do is that we are going to take the value of the element, and then at the end of the day we are just going to return the sum of all of the elements falling in this tree. Let's say we have this for instance, we have a range from 7 to 10, right? From 7 to 15. We are going to take this first one. Is 10 in the range? Yes. So at this stage our result is actually 10. Is 5 in the range? No. So we don't take it. Is 3 in the range? No, we don't take it. Is 7 in the range? No, we don't take it. Is 15 in the range? No. Is 7 in the range? Yes, we take it. So this is actually 17, right? Is 15 in the range? Yes, we take it. So this is actually 17 plus 15, which will give you 32. And is 18 in the range? No, so we don't take it. So basically what we are supposed to do is that we're just supposed to loop through our element, our graph, and then find out all of the elements that fall in the range and sum them. So now that we are aware of the scenario, how are we going to solve it? For us to solve it, we are going to use a recursion approach. Why? Because we can see that the sum of element of a given node is equal to the value of the node plus the sum of element of the left plus the sum of the element of the right. So we're just going to reuse that fact and implement a recursion approach with it. And one thing important is that whenever you are thinking about recursion, what is the base stage? So if a node is actually null, that means the value that the node is going to return will be 0. So how do we code it? So we're just going to say always think of the initial state. So if the node is actually equal to null, what you're going to say is that you return 0. And after this you can just say your result will be 0. This is actually what you want to compute. And what we say is that we said if the node dot val, how should the value be? The value should be greater or equal to the low, and the val should be less or equal to the high. If it's the case, then the result is going to take its old value, its whole value plus the val. And then after this we just reuse the fact that the value of a given node is actually equal to like the solution at that node plus the solution of the left tree plus the solution of the right tree. So we're just gonna say you take range, let me just copy so I don't make error, plus equal to this of node dot left, low and high. So after this you just need the same here for the right, and at the end you just return the result. We have already returned it. So this is how we are thinking about the solution. If the node is actually equal to null, you return 0. It will be for the cases where, you know, for 3 for instance, you are going to return the left and the right, and both need to return 0. If it's a valid node, like maybe this one, we need to initialize this as 0, and then we just need to check, is the value falling in the range? If it is the case, we just say okay, the result is going to take the value, and then now the final result is actually that value plus the value of the left node plus the value of the right node, and then at the end you return the result. Let us run and see what it gives. Everything is green. Let us submit. So perfect, everything is green. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.